Hello friends, you are watching ISC Mathematics and we are solving the exercise 4th, first exercise of chapter number 4th of chapter Determinants, ISC Mathematics class 12. Okay, now in the last video we have completed the exercise till question number 8. Now question number 9 onwards we will solve in this video. Okay, so let us solve question number 9 onwards. Question number 9. Okay, we here in exercise A we have to solve for x, that is you have to find the value of x. Yes or no? First determinant is given 1 1 1, 4 minus 2 2x, sorry 1 1 1 1x1, it is 1x1 and 1 1x is equal to 0. Okay, now it is very clear that the first column or the first row contains 3 ones, so you can get 2 zeros over here, yes or no? So on R1 minus R3 and on R2 minus R3 we will carry on. So we will get 0 0 1, then 0 x minus 1 1, then 1 minus x, 1 minus x and x, okay, equal to 0. Now we can expand along first row or first column. So let me expand along first column, yes or no? So equal to 1 into what will be the determinant? 0 1 minus x, 0 1 minus x, x minus 1 and 1 minus x. Let us simplify. So 0 into 1 minus x will be 0 only, 0 minus 1 minus x into x minus 1. Okay, if you take minus sign common over here, so 1 minus x will be x minus 1 and here minus minus plus, so plus x minus 1 into x minus 1 is equal to x minus 1 the whole square. Okay, equal to 0 is given on the right hand side. Remember, we have to find the value of x. Clear? So equal to 0 and therefore x is equal to 1. Okay, coincident roots. Since we got x minus 1 the whole square is equal to 0, so value of x is 1. Clear? So this is the first of 9th A, question 9th A. Okay, now let us find out, let us solve the second question. Second question, 1AB, 1XB, 1AB, 1XB and 1AX equal to 0. Now obviously this is also a similar kind of question. Since the first row contains 3 ones, so we can get 2 zeros, yes or no? So on C1 C1 minus C3 and on C2 minus C3 we will carry on, therefore 0, 0, 1. Okay, again A minus A is 0 and here we will get B minus X. Again X minus A and B minus X, Ax equal to 0. Clear? So you can now expand along any row or any column. I will expand along first column. So expanding along first column. Okay. So therefore we have B minus X into determinant 0, 1, X minus A and A equal to 0. Therefore B minus X into 0 minus X minus A equal to 0. Therefore now we have a minus sign, so I can change this sign, B minus X into X minus B, X minus B into X minus A equal to 0. Therefore X minus B is 0 or X minus A is 0. Therefore X is equals to B or X is equals to A. So we got the two values. In this case X is equal to A and X is equal to B. So this was the second question of 9th one. Now let us solve the third one. This is an IIT question. Okay, third number, elements 1, 1, 1 are given, 4 minus 2, 2x, 25 and 5x square equal to 0. Okay, again here we have 1, 1, 1. So on R1 minus R2 and on R2 minus R3 we will do. So on R1 minus R2 and on R2, let us subtract R2 minus R3 and therefore we will get 0, 0, 1. Okay, here 4 minus plus 2, 4 plus 2 will be 6 and minus 2 minus 2x, 20 minus 5 will be 15, 5 minus 5x square and 5x square. Okay, now we have two zeros on the first column, so we will expand along first column. Yes or no? So let us expand. Therefore 1 into we have determinant 6 minus 2 minus 2x, 15, 5 minus 5x square equal to 0. Therefore 1 into 6 into 5 minus 5x square minus plus 15 into 2 plus 2x. Okay, I have taken minus sign common from here. So minus will be plus, because in the middle we put minus sign, and if you take minus sign common, minus will be plus. Okay, now let us simplify. Okay, so 6 5s are 30 minus 30x square plus 30x is equal to 0. Therefore minus 30x square plus 30x plus 60 is equal to 0. Let us take minus 30 common. So x square minus x minus 2 is equal to 0, and therefore 2 ones are 2, and factorizing you get x is equal to 2 and x is equal to minus 1. So here we got the two values of x. One is 2 and the another one is minus 1. So this is the third one of question number 9. Okay, now let us solve the fourth one. Okay, so now this is number 4 of question number 9. We are given a determinant a plus x, a minus x, a minus x, again a minus x, a plus x, a minus x, then a minus x, a minus x and a plus x equal to 0. Okay, now it's very clear that if you add all the three columns on any one column, on C1, C2 or C3, like on C1, C1 plus C2 plus C3, or on C2, C1 plus C2 plus C3, or on C1, C1 plus C2 plus C3 you can take, or even on R1 plus R2 plus R3. Okay, in any way you can add the three columns or rows. Okay, you will get the same element in a particular row or column. So here on C1 I am adding C1 plus C2 plus C3. Okay, so if you add you will get 3a minus x, a plus a plus a, 3a minus x in the first column. Yes or no? Okay, then okay, similarly at the same time on C2, or do one thing here, since we will get 2 ones, so then we can get 2 zeros. Okay, so let us write down the remaining terms as it is: a minus x, a plus x, a minus x, a minus x, a minus x and a plus x. Okay, so we can take here 3a minus x common, so we get 1 1 1. A minus x, a plus x, a minus x, then a minus x, a minus x and a plus x equal to 0. Okay, now on R1 minus R3, and on R2 we will subtract R2 minus R3. Therefore 3a minus x 0 0 1, okay, 0, a plus, okay, here we will get 2x and a minus x minus 2x minus 2x and a plus x equal to 0. Now expanding along the first column. Okay, so expanding along the first column, we will get 3a minus x into 1 multiplied by the determinant of order 2 by 2 is 0 minus 2x, 2x and minus 2x. Okay, let us simplify. So we get 3a minus x into 0 and minus minus plus 2 to the 4x square. So we will get here 4x square into 3a minus x is equal to 0. Therefore x is equal to 0, or x is equal to okay, so this question is also over. Now, so all the 4 questions of 9th A exercise are over. Okay, now let us move further. We will solve the further questions. Okay, let us solve now part B of question number 9. Okay, question number 9, part B. Okay, here find the value of x from the given equation. Here also the same thing, we have to find the value of x. Okay, now number 1, we are given determinant x plus 1, 3, 1, 2, x plus 2, 2, then 3, 1 and x plus 3 equal to 0. Okay, now let us simplify this question. Okay, so what we can do, 3 plus 2, 5 plus 1, 6. Okay, so if you notice that if we add the 3 columns, okay, you will get the same term. So here also on C1 I am adding C1 plus C2 plus C3. So x plus 6 and x plus 6 we got, okay, 2 x plus 2, 2, 3, 1, x plus 3 equal to 0. Let us take x plus 6 common. Okay, so we will get 1, 1, 1, 2, x plus 2, 2, 3, 1, x plus 3 equal to 0. Okay, now on R1 minus R3 and on R2 minus R3 we will do, and therefore we get x 6, 0, 0, 1, 2 minus 2, 0, x 2, then minus x 1 minus x minus 2 and x plus 3. Okay, so now let us expand along first column. Expanding along first column. Okay, we will write now x plus 6 into 1. Determinant is 0 minus x minus x minus 2 equal to 0. Therefore, x plus 6 into 1 into 0 minus minus plus x square. Okay, so we will get x square into x plus 6 is equal to 0. Therefore, x is equal to 0 or x is equal to minus 6. So here we will get the two values of x. One is 0 and the other value is minus 6. So this is the first one of ninth B. Now let us solve the second one, second of ninth B. Okay, we have XAA, XAB and BBX equal to 0. Okay, now on C1 plus C2 plus C3, so we will get, okay, let me check whether it was XAB, this is XB, a lot of mistakes, and BX, okay, done. Okay, so on C1 we will add C1 plus C2 plus C3, so we get x plus A plus B, x plus A plus B and x plus A plus B, again A, x, B and B, B, x equal to 0. Now we can take common x plus A plus B, so we will get 1, 1, 1. A x b b b x equal to 0. Now on R1 minus R2 and on R2 minus R3. Okay, on R1 minus R3 and on R2 minus R3. Therefore, x plus A plus B 0, 0, 1, A minus B, x minus B, B, then B minus x and x equal to 0. Yes or no? Now we will expand along the first column. Therefore, expanding along first column, okay, we will write now x plus A plus B into 1. The determinant is A minus B, B minus x, x minus B and B minus x equal to 0. Therefore, x plus A plus B into 1 into, we have A minus B into B minus x minus minus plus here b minus x the whole square we will write. Okay, actually it is minus x minus b into b minus x. I have converted this b minus x minus b into b minus x. So for that we will take minus sign common. So here minus minus plus b minus x into b minus x will be b minus x the whole square equal to 0. Now from the two terms we will take b minus x common. Therefore x plus a plus b into b minus x common. What is left? The leftover terms are a minus b plus x okay plus b minus x because we have plus sign here equal to 0. Okay, now in this bracket plus b and minus b will get cancelled, so this bracket will be a minus x only, and therefore x plus a plus b into b minus x into a minus x equal to 0, and therefore x is equal to minus of a plus b first value, then x is equal to a second value, and x is equal to b. So these three values we will get, either x is a or b or minus a plus b. Clear? So these are the three possible values we got. So this was the second number of 9th B question. Okay, now let us solve C, question number 9C. I hope you have understood this very well. Okay, now we will solve 9C. Okay, question number 9C. It is given that if x is equal to minus 9 is a root of the equation, determinant equation is given tx6 7 2x equal to 0. We have to find the other two roots. Okay, one equation involving determinant is given, one root is also given, we have to find the other two roots. Okay, so we will find out. Okay, we are given this equation. Okay, here we are given, what we are given, that x 2 7 3x6 and 7 2 x is equal to 0. Okay, even if you don't simplify, we can directly multiply or directly expand this one. So let us expand along first column. Okay, so therefore x into bracket x square minus 6 to the 12 minus 2 into bracket, I am writing directly over here, or let me show one more step. Okay, x multiplied by the determinant x to 6x minus 2 3 7 6x. Okay, and 7 3 7x and 2 equal to 0. Now we will solve. Okay, so now this 2 by 2 determinants you know how to solve. X into x square minus 12 minus 2 into 3x minus 42 plus 7 into 3 to the 6 minus 3 to the 6 minus 7x equal to 0. Let us simplify this equation. So we will get x cube minus 12x minus 3 to the 6x plus 42 to the 84 plus 42 minus 49x equal to 0. Therefore, x cube, yes or no? X cube minus 12x minus 49, 12 minus 6 minus 18, minus 18 minus 49 minus 67 x plus 84 plus 42 126. These two constant 126 is equal to 0. Okay, that one 18. Yes or no? That is right only. 67 minus. Okay, now it is given that. Let us give this equation number 1. Now it is given that x is equal to minus 9, therefore x plus 9 is equal to 0, and therefore x plus 9 is a factor, yes or no? Therefore x plus 9 is a factor of equation 1. So we will divide this equation 1 by x plus 9 to find the remaining factors or remaining values of x, yes or no? Clear? So this was a simple expansion and this is simplification of the equation. At the end we got this cubic equation. In the question already given that x is equal to minus 9, so x plus 9 is equal to 0, therefore x plus 9 is a factor of equation 1. Okay, so we will divide this equation by x plus 9 to get the other values of x. Okay, so therefore let us divide. This is x cube minus 67x plus 126 divided by x plus 9. Okay, we'll multiply by x square, so x cube plus 9x square. Okay, minus 9x square minus 67x. So by 9 minus 9x we will multiply minus 9x square minus 9 9s are 81 plus minus minus. So now let us change the signs. Okay, so 80, 67, 13, so 14 is the remainder, 14x plus 126. Now finally we will multiply by 14, so we will get 14x plus 126, 0 remainder, and therefore now we got the factorization. Therefore x cube minus 67x plus 126 is equal to 0 can be written as x plus 9 into x square minus 9x plus 14 is equal to 0. Now we know that x is equal to minus 9 is already given. So now we will factorize this quadratic equation and find the two required values of x. Okay, and therefore x square minus 9x plus 14 is equals to 0, x minus 7, x minus 2 equal to 0, therefore x is equal to 7 or x is equals to 2. So these are the other values of x are 7 and 2. Clear? So this is the answer. Question number 9C we have completed. We got the two values to be 7 and 2. Okay, now let us solve question number 10. Okay, question number 10. Two sums are similar. Okay, I will solve one and the other you will try yourself. I am solving the second question. The first one you should try, and if you have doubt then you can ask me. Okay, now question number 10. Question number 10. First one you should try. First and second both are similar. I am solving second one. We have to prove that 1 a square a1 a square a1 is a perfect square. Okay, so we will simplify and we will find the value of determinant which must be a perfect square value. So you are given the determinant 1 a square a1 a square a1. Okay, on C1 we will add C1 plus C2 plus C3. So we will get a square plus a plus 1, a square plus a plus 1 and a square plus a plus 1. Okay, a1 a square a1 equal to 0. Let us take a square plus a plus 1 common from the first column. A square plus a plus 1 1 1 1 a1 a square a1. Okay, equal to 0 is not given in this case. So we have taken from the first column a square plus a plus 1. Okay, now we got 1 1 1. So you know very well then what is the next step. We will get two zeros over here. So on R1 minus R2 and on R2 minus R3 we will do. Okay, now on R1 minus R2 and on R2 minus R3. Therefore a square plus a plus 1 into 0 0 1 a minus 1 1 minus a square minus a minus 1 1. Okay, now we will expand along first column. Okay, let us expand along first column. So we will get over here a square plus a plus 1 into 1 into a minus 1 a square minus a 1 minus a square and a minus 1. Okay, now we will further simplify this 2 by 2 determinant to get the final answer. Therefore, or we have a square plus a plus 1 into 1 into we have a minus 1 the whole square minus 1 minus a the whole square into a square minus a. Okay, now let us simplify. A square plus a plus 1. Okay, here we have a minus 1 the whole square. Okay, here 1 we have a 1 minus a the whole square. Let us take minus sign common, so it will be plus, so we will get a square minus 1. Okay, from here if you take a common, we will get a minus 1. Okay, now let us further simplify. So a square plus a plus 1, okay, into we have a minus 1 the whole square plus, okay, here a minus 1 into a plus 1 into a minus 1. Okay, so a minus 1 will be a minus 1 the whole square. So a square plus a plus 1 into a minus 1 the whole square plus a into a plus 1 into a minus 1 the whole square. Now we can take a minus 1 the whole square common from both the terms. So a minus 1 the whole square into a square plus a plus 1, and inside we will get 1 plus a into a plus 1. So on simplification we will get a square plus a plus 1 into a square plus a plus 1. So finally a minus 1 the whole square into a square plus a plus 1 the whole square, which is a perfect square quantity. Yes or no, is equal to perfect square, and hence we have proved. Okay, we have to prove that the determinant its value is a perfect square. So obviously both the brackets are square brackets, so it is a perfect square. Clear? So first one is similar, only you should try. Okay, now let us solve the third one of question number 10. I hope you got this question. Okay, now let us solve the third question. Question number 10, third one. We have to prove that you are given a determinant a plus 2, a plus, okay, first is a plus 1, a plus 2, then a plus 2, a plus 3, and a plus 3, a plus 4. Okay, we have a plus 2, a plus 3, and a plus 4, 1, 1, 1 equal to minus 2. We have to prove that the value of the determinant is minus 2. Let us take the left hand side. Okay, LHS is given a plus 1 into a plus 2, a plus 2 into a plus 3, a plus 3 into a plus 4, a plus 2, a plus 3, a plus 4. Okay, now we have to simplify. You can see that in the third column we have 3 1s, so we can get 2 zeros over there and then simplify it. So on R1, or let me now take here on R3, R3 minus R2, and on R2 I will take R2 minus R1. So first on the third row, okay, so there will not be any change in the first row, yes or no? So let me write the first row as it is. Okay, on R2 minus R1 we are doing. Okay, so a plus 2, a plus 3. Okay, you can take a plus 2 common. Yes or no? This minus this. So in both a plus 2 is common. So a plus 3 minus a plus 1. So 2 into a plus. If you don't understand in rough, you can do this subtraction. Yes or no? Second minus first. This element is common. So a plus 3 minus a minus 1. A will get cancelled. 3 minus 1 will be 2. Similarly, this minus this, if you do, you will get, okay, again 2 into a plus 3 will be common here. So we have a plus 3, a plus 4, and over here 0 0. Okay, now we can expand. Okay, if you don't do any further step, it will do, because we got the 2 zeros. Let us expand along the third column. Okay, so expanding along the third column. Okay, therefore 1 into what will be the determinant? 2 into a plus 2, 2 into a plus 3, a plus 3 and a plus 4. Okay, is equal to 2 into a plus 2 into a plus 4 minus 2 into a plus 3 the whole square. Now let us simplify. So 2a square, 4 plus 2 6, 6 2s are 12a. Okay, or you can take 2 common from both the terms. So let me write down 2 outside only. Yes or no? So 2 I will write outside here, a square plus 6a plus 8 minus a square minus 6a minus 9. Okay, so a square minus 6a plus 6a minus 2 into 8 minus 9 will be minus 1 is equal to minus 2, which is equal to RHS. Just look at the simplification. Okay, diagonal product of diagonal elements minus product of off diagonal elements. This 2 is common to both the terms, so we have taken it common and then we have simplified inside. So we will get minus 1 in the bracket. So 2 into minus 1, that is minus 2. Clear? So question number 10, third question is also over. Okay, now let us solve question number 11. I hope you are getting all the questions I have explained you today. Okay, now we will solve the next question, that is question number 11. Okay, question number 11. Number 1. Okay, we have to show that a determinant a square, b square, c square, a, b, c and 1, 1, 1 is equal to minus into bracket a minus b into b minus c into c minus a. Okay, let us take the left hand side. Okay, we are given a square, b square, c square, a, b, c and 1, 1, 1. Now it is very clear, if you have 1, 1, 1, what you are going to do on r1, r1 minus r2 and on r2, r2 minus r3. On r1, r1 minus r2 and on r2, r2 minus r3. So a square minus b square minus c square, a minus b, b minus c, 0, 0, 1. Okay, if you factorize a minus b, a plus b, yes or no? So we have a minus b, a plus b, a minus b is 0. Again here b minus c, b plus c, b minus c 0 and c square c 1. Okay, so you will notice that from the first row we can take a minus b common, and similarly from the second row we can take b minus c common. Yes or no? From here a minus b and from the second row b minus c. So outside now we can write equal to a minus b into b minus c. Now what is left in the determinant is a plus b, b plus c, c square. Okay, 1, 1, c, 0, 0, 1. Okay, now we can expand along the third column. Yes or no? So expanding along third column. Okay, so a minus b, b minus c into 1 into the determinant will be a plus b, b plus c, 1, 1. Okay, so simplifying a minus b, b minus c into 1 into a plus b minus c. So here plus b minus b will get cancelled. So we will get a minus b, b minus c and a minus c. If you take minus sign common, so it will become minus of a minus b, b minus c and c minus a. Hence we have proved. Clear? So this was also an easy question. Okay, now let me solve the second question of question number 11. Okay, here we have to show that I will keep certain steps as they are. Okay, here we are given to prove that 1 alpha beta gamma, 1 beta gamma alpha and 1 gamma alpha beta is equal to beta minus gamma, gamma minus alpha and alpha minus beta. Okay, this we have to do. Let us take the left hand side. 1 alpha beta gamma, 1 beta gamma alpha, and 1 gamma alpha beta. Okay, before we subtract 1 1 1, look at this third row. Here beta gamma, gamma alpha, alpha beta. Okay, this is beta gamma. If we somehow bring over here alpha or multiply this term with alpha, so it will be alpha beta gamma. Clear? And similarly here gamma alpha is there, so if you multiply somehow with beta, so it will be again alpha beta gamma. Similarly here you multiply by gamma, so you will get again alpha beta gamma. So in the third row each element will be alpha beta gamma, so we can then take common. Okay, so in order to bring here alpha, what we will do, we will multiply the first column by alpha. So we will write down that on C1 alpha into C1, on C2 beta into C2, and on C3 gamma into C3. Okay, so remember a rule, when you multiply, then outside you have to divide also to keep the values unchanged, yes or no? So we are dividing, since we are multiplying by alpha, beta, gamma, respectively the first, second and third column, so we will divide by alpha, beta, gamma. Clear? So now first column will become alpha, alpha square, alpha, beta, gamma. Then second column will be beta, beta square, alpha, beta, gamma, and third column will be gamma, gamma square, alpha, beta, gamma. Okay, now alpha, beta, gamma we can take common. So alpha, beta, gamma upon alpha, beta, gamma, we get alpha, alpha square 1, beta, beta square 1, and gamma, gamma square 1. Okay, now if you notice this question, okay, after bringing two changes in this, okay, we will get the same determinant as we have solved in the second part of question number 11. Yes or no? This is the yes, second part. Okay, first one we have solved. So okay, this is the second part. So in the first part, what was the determinant starting from a square, b square, c square, abc, and 1 1 1 column wise entries. Yes or no? So here let us make few changes. Okay, therefore 1 into alpha, beta, gamma, alpha square, beta square, gamma square, 1 1 1. Okay, since A transpose is equals to A. Okay, that is determinant. Let me write down determinant of A transpose is equals to determinant of A. So if you, whether you write a determinant or take its transpose, the values will not change, values will remain the same. So I have taken a transpose, that is I have changed each row into each column. That is one property only, that if all the rows are changed into columns, the value of the determinant remains unchanged. So we have used that property over here. You can write the reason in this way. Clear? Now few changes we will make. Okay, we will interchange, yes or no, the first and the second row. Clear? So let us interchange. Okay, so on interchanging first and the second row, value of determinant will be minus alpha square, beta square, gamma square, alpha, beta, gamma, 1 1 1. Okay, since what we have done here, we have changed the second and the first column, so sign will be minus. Now the value of this we know. Now the previous question we will use as a result. Okay, or if you want to do steps, okay, you can follow the same steps. Okay, subtracting on R1 minus R2, and on R2 minus R3. In that way you can proceed. On R1 minus R2 and on R2 minus R3. Okay, now this is the similar question to number 1. In case of alpha, beta, gamma, we had there a square, b square, c square, a, b, c and 1, 1, 1. Just check the first question of 11th one. Okay, so the same result is going to come. What is the result? A minus b, b minus c, a minus c. Okay, or minus a minus b, b minus c minus a. So here we will get minus alpha minus beta, beta minus gamma and gamma minus alpha. So minus minus will be plus. Okay, so that will be the answer. But let me show all the steps over here. Okay, so we will write down that minus alpha square minus beta square minus gamma square, alpha minus beta, beta minus gamma, gamma 0, 0, 1. Okay, take alpha minus beta from the first row and beta minus gamma from the second row. So alpha plus beta, beta plus gamma, gamma square 1, 1 gamma 0, 0, 1. Expanding along third column. Okay, so minus of alpha minus beta into beta minus gamma into 1 into alpha plus beta, beta plus gamma, and finally solving the 2 by 2 determinant, you will get the answer. Okay, so let us solve the determinant. So minus alpha minus beta into beta minus gamma into alpha plus beta minus gamma. So we will get minus of alpha minus beta, beta minus gamma and alpha minus gamma. Finally take minus sign common from the last bracket, so it will become plus alpha minus beta, beta minus gamma and gamma minus alpha, which is equal to right hand side here. So the first 2 or 3 steps are different, then the question is similar to number 1 only. Okay, so remember this pattern, all the patterns of this kind where you get a square, b square, c square, column wise entries, a square, b square, c square, a, b, c and 1, 1, 1. So you will get always the same answer, that is minus of a minus b, b minus c, c minus a. Clear? Okay, so the second one we have solved. Now the third and the last of question number 11. Okay, now third one, we have to prove that b plus c, c plus a plus b, a minus b, sorry, it is b plus c, c plus a, c, b, a, c, b and b, a, c equal to a plus b plus c into a minus c the whole square. Okay, again a simple question. Let us take left hand side. LHS b plus c, c plus a plus b, a, c, b R1 plus R2 plus R3. So you will get here in the first term 2 into A plus B plus C. The other terms will be A plus B plus C, A plus B plus C in the first row. Second and third row we will keep as it is for now. C, B, A, C. So now we can take A plus B plus C common. Okay, so let us take A plus B plus C common. A plus B plus C common. So we are left with 2. C plus A plus B, 1 C, B and 1 A, C. Clear? Now on C1, further simplification on C1 minus C2 plus C3 I will do. I will add the second and third column and subtract from the first one. So what happens, let us check. Okay, obviously 1 plus 1 2, so 2 minus 2 0, again over here 0, and A plus B minus B, so we will get over here A minus C, 1 C B and 1 A C. That's all. Now we will expand along first column. So expanding along first column, we will get A plus B plus C into A minus C into 1 C and A. Clear? So again, first step on R1 we have added the 3 rows, so we got 2 into A plus B plus C, A plus B plus C, A plus B plus C. We have taken A plus B plus C common, so we got 2 1 1. Then next operation on C1 minus C2 plus C3 I have done, so I got 2 zeros. Then I have expanded along the first column. Now let us further simplify on the left side. Okay, so we will get over here A plus B plus C into A minus C into A minus C. Yes or no? And therefore A plus B plus C into A minus C the whole square is equal to right hand side. Clear? So question number 11, third one we have solved. So far we begin with question number 9. So 9, 10 and 11 we have solved. Only one question of 10th and first one I have left for you. Remaining all we have solved. In the next video we will proceed from question number 12 onwards. Okay, and still many more questions are there to be left. Okay, so thank you very much.